much like space exploration, a lot of the cost is in the logistics. Let's collect data quickly, let's collect the right sort of data, and let's get it out of the field, and maybe you learn something while your logistics cost and your people are still there, and you can then act on it.
Well, welcome to Mining Now, and we're live from the trade show at PDAC, the Prospector and Developers Association Convention, the big convention in Toronto, Canada. And my name is Roy Slack, and I'm your host today for another edition of Mining Now. And it's my pleasure to be joined by Anthony Reid, who's head of geology, and Darren Burrows, who's an exploration physicist from Fleet Space Technologies. Gentlemen, thanks for joining us today.
Not a problem.
Thanks, Roy.
And I always like to start out by learning a little bit about our guests. And Anthony, let's start with you and give us a little bit of your background and how you ended up with Fleet.
Well, so I absolutely love geology, which is a kind of a fault, but also, it's kind of good as well. So, I spent a lot of time working in the geological survey space, which is all about research. It's all about understanding the rocks. It's still mapping but integrating geophysics and geochemistry and other methodologies. So, had a lot of work there. I did some consulting work, and now I've joined Fleet Space through to kind of broaden what I'm understanding about geology and trying to contribute to the industry.
You reminded me of a quote. There was someone you mentioned. What would they say? It's all about.
Well, yeah, it is all about the rocks. So Gary Delaney, a very famous geologist out of Saskatchewan, one of his classic quotes, although I did think it was personally given to me, but it's okay. He says it to other people as well, is it all starts with the rocks. And I think that's super important. And the mining industry and minerals industry, there's a lot of downstream activity, all that down towards, the mining.
Doesn't happen if the rocks aren't there.
If the rocks aren't there and if we don't understand which rocks are where. Yeah.
Yeah. Which is a very fitting quote for where we are, the Prospector and Developers Conference, the big conference. And Darren, your turn.
So, similar to Anthony, I'm a bit of a science geek as a kid, and I was always a bit of a space geek as well. And when I went to university, I went to a geology lecture, and I thought, oh my God, I can't color very well with pencils. And so let me actually do some real science.
Okay.
Well, you wanted more equations.
I did, absolutely. And
we'll
I was the exact opposite of you.
We'll be putting this out to the schools to attract people to you.
That's right. No, I enjoyed geology, but I did want something a little bit sort of more data-driven, something with cool instruments and, shiny, buzzy, beepy things. And so geophysics was something
that makes sense.
Yeah, it does, right?
Yeah.
Yeah, very good. And I'm not sure who wants to take on this next question because for our audience, give us a little bit of background about Fleet Space Technologies.
So Fleet is a space company, and they started about 10 years ago. So this year's a Fleet's 10-year anniversary.
Okay.
And point when they started was to change the small satellite game. There are lots of billion-dollar satellites that go into geostationary orbit. But really, if we can build smaller, lighter, cheaper space hardware, we can leverage them to do interesting things on the ground. And so, it started off with space and building satellites, and that's what we still do. Our latest satellite launch was in January. We launched 2 satellites.
I had to get up very early in the morning.
You did
to watch that. Actually,
it was right. My afternoon was fine.
I know.
But we about 3.5 years ago, figured that mineral exploration is as hard as space exploration, right? These are 2 very difficult things to do. Yeah. Difficult environments to work in, difficult numerical problems to solve, et cetera, et cetera. And so what we now do is we make geophysical sensors, and we live stream that data through our satellite network and into a processing platform. And it's really space-enabled exploration. So how can we leverage space assets to do a better job of exploring for minerals on the Earth? Fleet also is sending some of these instruments to the moon. And so in 8 months or so, we'll be launching a seismic instrument to the moon with some partners. We're not launching anything. We're going on a lander, but we'll be collecting seismic data on the moon beginning of next year. So that's really, really exciting.
So we talked about this before very briefly, but the name of the company, Fleet Space Technology, and I knew what your company did, but I didn't know how space fit in. And so your explanation is great. Now I get it. Leveraging that space technology to help us.
Yeah. So when you're
on Earth.
when you're exploring the moon, or if there's people, or robotic exploration of Mars, what sort of characteristics of the instrumentation and the infrastructure required to communicate with that instrumentation do you need in that environment, in that place? How do you get extremely good quality data very quickly to make decisions as close as possible to near real
From
time
an extremely remote area.
when you only have a short amount of time
Yeah.
to get there, right? So, and this is classic field exploration as well. You have a short window of time to do something.
Yeah.
Northern Canada, snowed in, ice everywhere, you can't do anything.
Yep.
What can we do in the field season we have? So it's a similar principle. So I think it's that really taking that space kind of concepts and what would we need there, and then realizing there's so many parallels.
Yeah.
Yeah.
And much like space exploration, a lot of the cost is in the logistics. Getting the thing to the moon costs $1 billion. Getting the field camp out to northern Yukon costs a lot of money.
Yeah.
Right? So how do we efficiently use that logistics cost that you've already sunk in there?
Yeah.
Let's collect data quickly. Let's collect the right sort of data and let's get it out of the field. And maybe you learn something while your logistics cost and your people are still there, and you can then act on it. Right? It's about acting on data as quickly as you can. And that's how you make things efficient.
I love the parallel concept of if you had to do this in space, what would you do? Once you figure that out, you can apply that on Earth.
But we're also taking things that we do on Earth. So we've done some testing with NASA on one of the big resources that people are going to find in space. Not going to be nickel in asteroids. It's looking for water ice on the moon.
It might be nickel in asteroids, to be fair, but to start with,
let's start off. We're going to try and make sure people can survive in space, which is hard. But we've tested on Earth what is the seismic response of ice, of glaciers. We've collected that data. We've characterized it here so that we can do it more efficiently there. We've collected data over lava tubes. If people go to the moon, they need somewhere to stay. The moon has no atmosphere. It has no magnetic field.
Yeah.
Hardcore radiation environment. So the best place to live is underground. You don't want to excavate. Find something there's already a hole.
Yeah.
Geophysics is going to do that. Gravity, seismic data, we'll be able to find these lava tubes, and we collected some data of the lava tubes in the Seychelles. Yeah.
Canary Islands.
Oh, Canary Islands. Sorry. Yeah. Other side of Africa.
Well, you know what? I'm going to bring it back to Earth.
Okay.
And we're going to talk about mining and exploration, and we talked about this earlier too, about the challenge of poor data. And if you've got incorrect data, incomplete data, all of these things are a big challenge on projects, and even more so on the exploration cycle. So you guys are dealing with that.
Absolutely. So one of the things, I've been in the geophysics industry for 20 years, and often it's when your aeroplane or your field crew has moved out of the field and you've now got all of your data, you start going through it, and you often find quality issues, gaps, etc., etc. But now you're too late. You've moved on, right? So maybe you have to go fill that gap in next season. If you can connect your instruments to live telemetry and live data connections, process that data quickly, but really just look at the quality of it. And if there's a problem with it, you're now in the field and you can mitigate that, right? So it's about taking action.
You get immediate feedback.
And so with a lot of our data sets, that field data quality goes away.
Yep.
Right?
That issue.
It's very transparent.
Yeah.
And if there is an issue, you can talk with your client. You can figure out what is the compromise we have to make, and do it together in a transparent way.
Yeah.
It's not 6 months or 6 weeks down the line whenever you're getting your final model. Whoopsie. This is something you can act on immediately. And so that data quality and that being able to be a little bit more sort of fleet of foot in the field is valuable.
How many minutes have we been in? And
Okay. You know what? I have a personal rule. I try not to use puns on the show, but you've just opened
all
this
the
up.
Oh, here we go.
Some dad and granddad jokes.
That's 6.
Okay. This is
Data quality is really
I got to look
important.
back at my sheet.
But the data quality issue,
Yeah.
what you make decisions on in the geological space, you're relying on your geophysics team. You don't understand the equations. You're not there processing data. You're not going. They show you a data quality plot, and this has happened.
Yeah.
To me, and you don't know any. They just say the geophysicist shows you a plot and says, "Oh, the data is good quality," and you nod sagely, but you think to yourself, "I don't even know what the X and Y axis is showing me." So you need to have confidence that the geophysicists have collected good quality data, and they're going to supply that, because you're going to make decisions that is going to be your reputation and your kind of your company money that you're spending.
Well,
So that's why data quality is.
you know, and I'm trying to relate to it. If you're in the field, and you have some people in the field, but once you can transport that data or transmit that data, now you can have a whole range of expertise looking at it.
Yeah.
So
They
instead
could
of
be
that,
anywhere. Yeah.
instead of that drill manager in the field saying, "Yeah, we got everything we need," you can have a group of people saying, "Well, did you look at this? And while you're out
This-
there, please do this." And so it just really expands the amount of expertise you can apply to that.
It does. And one thing that data quality does is it cascades through the life of your project,
Definitely.
right? So get it right the first time. It saves you a bit of time, etc. But it's also really efficient because as we're moving into more of a sort of data-driven AI software space, high quality data is very important to AI models.
It is.
So, you know, as we move to the future, that data quality is going to get more and more important, and it's an initial investment that really does cascade down into for the life of your project.
Yeah, it's a digital investment.
That's it.
Well, the speed of processing the wrong data doesn't help you, right?
Yeah.
Well, this is true.
Yeah. So now I've got a mining engineering question.
Oh, please.
Okay.
Please.
Yeah.
But or I shouldn't say that. This is something I understand as a mining engineer, but mines are going deeper. Grades are going down, and exploration is getting more challenging.
Definitely,
Naturally.
definitely, yep.
So you guys are looking at that. Well, you're dealing with that because that's the nature of our industry. So deep mines.
So what you want are instrumentation and methodologies that can see, ideally in 3 dimensions.
Yep.
You know, so there's lots of data types that we'll see in 2 dimensions.
Traditionally.
Yeah, and they're really valuable and really important to integrate that.
Yeah.
But to couple that with information which you can see, at depth and in 3 dimensions, so you actually are constraining the information that you're getting from your geophysical methods is constraining something about the subsurface at a depth.
Yep.
So you're not having to project or do some other transformations. They are very useful, but this is, so what I'm getting at here is things like seismic, which is something that probably is quite underutilized.
It is, and we made a deliberate choice to choose seismic data. We collect a lot of different data sets, but we're focusing on seismic data, various types of seismic data, because it scales very well with depth, better than gravity, better than magnetics. It doesn't have some penetration problems that electromagnetic methods have. And so we've deliberately chosen seismic data, but we do and are building tools that will collect those other types of data sets, because you don't just want one physical property. You want to understand as much about the subsurface as possible.
Yeah.
But that's built on the back of seismic. Seismic really is that kind of depth scaffold.
Scaffold. I was hoping you would say that word.
Yeah.
It's a great word, actually.
It is a good word.
It's a very visual metaphor for putting something else on something.
Yep.
And I think of, as a geologist, working with the seismic data, with all the fleet space seismic data, has been incredibly interesting to see just how much geometry you can understand, just how much sort of structural information or lithological information you can get from being able to say, wow, there's actually a whole layer here, or there's a shape. And in one of our surveys, there's this amazing survey which we've done, which you can see shapes in the seismic velocity, which correspond beautifully to igneous intrusions, to some sort of granitic body that you're actually looking at in 3 dimensions. It's fuzzy. I'm not like picking out individuals, but you can see there's a body in here that corresponds to other things we know that are magmatic features.
And that model that we created was mapping structure. We did it down to 5 kilometers. Now, no one's going to mine at 5 kilometers.
Oh, no.
But a lot of the majors.
Maybe.
Well,
we're
maybe.
getting pretty
hot
close
down
in a
there,
couple
though.
of.
I've been 4
Is
kilometers
one
down a
there.
gold mine many times. Let me tell you, it's uncomfortable.
Yeah.
Well, then we get robots to do it, I guess.
That's
or
what
we
do.
could send you down there.
Well, maybe I'm a robot.
You like equations more than me, so I'm suspecting there's a bit of maths going on.
Well,
We can edit. We can edit the show.
that's okay.
We never do.
Was that bad?
We
Come
never
on.
do. One of the reasons, though, for imaging at depth is and a lot of the majors have been thinking about these ideas for a while, but it is understanding the mineral system, right?
Yeah.
So fine, you've got a deposit, but that deposit is the culmination of millions or hundreds of millions, or in some cases billions of years of geological overprinting, and that comes from starts at depth with picking up these the metals from somewhere and transporting them to the surface, and then you get an ore deposit. But understanding more about that system is going to help you find these blind deposits.
Definitely. So we're talking mineral systems a lot about architecture.
Yeah.
Right.
Yeah.
So, you've got other elements of your geology which build into the mineral deposits, but it's the architecture, the framework, the structures are often, they say structure is king. That's one of another cliche that is used. But
I thought it was all about the rocks.
well, that's another, you've got more than one
yeah.
cliche.
Okay, all right, fine.
Actually,
The structure about the rocks is king.
Absolutely.
yeah, that's so structures, weaknesses, things like that help focus metal bearing fluids in, and that can be at the at the superficial level, maybe in the when you have uranium deposits where you don't necessarily have a big deep something sinister going on at depth. You've got kind of processes happening near the surface, but they are still controlled and helped focus by structures. So using technologies and techniques which can image structure is super important.
And we talked about it briefly before, but I won't say traditionally, but originally I always thought as a mining engineer that the drilling would define the ore body. We could do a stoping plan. We could figure out how to mine it. But you begin to look at the big picture where, sure, you want to define a stope or you want to define an ore body, but what you really want to do is understand why it's there, how it's there, what...
Yeah, there's very practical considerations as well, because... You not only, I mean, I love to find out why it's there. That's what drives me as a scientist. But from a practical point of view as well, where are you going to put your tailings? Or where are you going to put the processing plant? You don't want to put that on the extension of the ore body. So this is where there's lots of examples where an ore body would be plunging at depth, and then a nice big fault's come along.
Lots of examples,
and away it's shifted over there. So imaging that near mine environment imaging, and I guess brownfields exploration is super important. And again, seismic, not but
imagine doing more of that work up front. So imagine as a mining engineer, you had far more trust and confidence in being able to make a mine design that is going to last 30 or 40 years, and that data is accurate, instead of changing it as you go along, right?
It just it completely changes the risk model.
Well, the return on investment is huge for that.
This was in the brochure, light touch sensor deployments. How does that fit into the exploration process? That's a term I'm not familiar with.
Light touch.
Yeah.
So this is where the sensors themselves don't require, or are designed not to require a lot of, I guess, excavation or kind of,
wires, connections, cutting of lines,
currents going into the ground,
exactly.
That sort of stuff. I mean, those things may be important, and they're super important, but it's still it's all about what's your cascade of methods that you're using and what stage you're at. Of course, there will be times when you need to pump that current into the ground, and you've got to do that, right? So, but in the earlier stages, you're not necessarily wanting to do a lot of ground disturbance. And that
or you might not be able to.
Or you might,
depending on your permitting, depending on
exactly.
local kind of conditions, communities, all those.
So finding out as early as possible, as much as you can, before you need to get into future stages, can be very helpful.
One of the advantages of these very simple sensors that don't need wires and currents and technicians is we've had a lot of local communities do the deployment.
Okay.
And so they can get involved.
That's a really good point.
It's amazing to kind of get them engaged and involved in this thing. We've got to remember that we're doing exploration in their backyard. There's all of these NIMBYs not in my backyard, but you're doing it in someone's backyard, right?
Yeah.
And so these typically are rural communities, especially in Canada, First Nations, to get them involved, to get them to see, listen, we're not destroying any heritage. We're not destroying any land. We're just, digging a small hole, putting a sensor in, and we leave it there. And we collect the passive seismic information that comes back. Yeah. And even if we do collect active source seismic to make it as light touch as possible. So we're developing new energetic sources, but that are very low energy, and we leave them in there for a long time. So instead of dynamite or a big vibrosized truck or something, which is very useful, it creates great geophysical signals, but in certain cases, maybe you want a lower energy source. You want something that's just going to rumble away slowly. But again, local people could deploy that. They could be involved in that. There's no danger to them, and hopefully they're engaged and they can be involved in this process.
I really like that point, because I was looking at it from a technology aspect. and you brought in the community it's an opportunity for community engagement.
Absolutely.
That's great.
Yeah, in the right circumstances.
We've touched on this before, but we're starting to deal with a huge amount of data everywhere, every industry, and mining's no different. And we're talking about AI, we're talking about robotics, and you guys are doing that, but I think you made the point earlier that all of this without expertise in human interaction doesn't work.
Well, you can't rely on ChatGPT to write your essay.
Yeah.
Because it's a model.
Yeah.
And all AI is it's picking statistical kind of covariance of multiple dimensional,
Yeah.
which we can't picture up. But you still need to have, vetting or kind of a vetting of that.
Yeah.
Yeah. So of course they've got to go together. And I think there's been some great talks here at PDAC, and one that I saw yesterday was was really talking about that, the importance of the partnership, the human machine. Why do I look at you when I said the human machine partnership?
Do you know something I don't know?
Having them together is the most powerful.
You said
way.
earlier you might be a robot.
Well,
that's
exactly
what I remember from
that's
the
exactly
having
right.
concern there.
It's human part. But that also comes back to the excellent quality data, and there's been some great other presentations that I've seen where the people have shown early, maybe 1950s sort of iterations of geophysical, imaging, and that was collected at a certain spacing, and so the features you see, while they're going to be features like that in the area, the sharpness or the resolution of that is much kind of.
So I was at a geophysics symposium on Saturday, and there was a story about the discovery of Olympic Dam.
Oh yes.
And people were taking regional gravity and magnetics maps that were hand contoured and
yep.
overlaying them on light tables, right? And trying to see, okay, where is there going to be a magnetic and a gravity anomaly together? These are great things for IOCGs.
Yes.
And we're going to drill that to try find some copper, right? That's what they were trying to do. And the magnetic anomaly was quite clear, but the gravity anomaly was kind of linear. And they're like, oh, that's unfortunate. Until the geophysicists went back to the gravity station data and went, oh, someone's contoured it this way, but I can just contour it that way.
Wow. Yeah.
And that lines up. There's
now
two
a sector.
bullseye. And they drilled Olympic Dam.
Yeah. Right. Yep.
Because someone recontoured the data.
So
But that original data was high enough quality that it could do that.
You could do that. Yeah. Yep. Yep.
Right?
Useful. Very useful.
So that's a lead in or a segue to what I was going to ask, because we're talking a lot about equipment here, space age equipment, right? Anyway, we're talking a lot about high tech equipment, but your group does more than that. It's not just providing the customer with some equipment to better define what they have in the ground, but you're involved in partnering or helping the customer beyond that.
Yeah, and so, we were discussing AI earlier, and so we were collecting high-quality data. We've got geologists and teams of geoscientists interpreting that, but we've added another layer on top of that recently. And you were saying, well, the mining industry is swimming in data. We're not.
Yeah.
We're not.
Is it really?
The amounts of data that Tesla needs
relative.
to train their self-driving cars, the amount of data that OpenAI uses for ChatGPT,
Yeah, absolutely.
we're nowhere close to that.
Not even close.
Exploration is a data-poor scenario. It really is. Big data does not apply to exploration yet, and so we're trying to change some of that. But so you can then go, well, how do you use AI? And again, it's that people machine together. And so a lot of the insights that we're getting out of our AI tools, yes, we're getting prospectivity. Yes, we're helping our clients plan drill targets and getting great feedback on that. But some of the most interesting insights are on what types of data are the most important, what scales of data are the most important, how does quality affect those predictions. And so it really is. There was a great talk by Cam McQuaig from BHP, and he was talking about this triangle. So you need people, you need really intelligent software, and then you need architecture that the software and the people can use to kind of interact and make something out of these data sets. Yeah. But without any, if one part of that triangle goes away, your outcomes are poor. And so we absolutely stand by that. That's really good insight because that's what we're seeing as we go down this AI journey. And it's going to change. This is fledgling, right? So we're, as an industry, we're starting to get into data science, but certainly we've lagged behind the oil industry a bit. But it's a far easier problem to solve with kind of flat-lying geology and limited minerals involved.
That's easy, right?
Yeah, but we're certainly behind the real high tech, electric cars and
but even
autonomous moon landers and things like that.
Yeah, even with our fledgling AI that we're working on, there's actually that talking about that symbiosis or the sort of connection between the geoscientist and the data and what I found really interesting is how the machine will throw out. It's not throwing out ideas; it's just throwing out here's an area of interest. And what it does is it forces you to go back and think, well, can I explain that?
It's bringing to your attention.
Yeah, areas that you might not...
It's not saying this is great or not. It's saying you should look at
There's a statistical correlation here, it's over to you kind of thing.
Well,
so
and it ranks, it tells you why it thinks, with there's a velocity anomaly of this and there's et cetera, and then you go back and look at the velocity anomaly. And if you have the quality information, if you've ranked what your quality looks like, and you actually go, oh, but that velocity information is actually of poor quality, and that's what the AI is basing this on. That's probably not a high priority target,
absolutely,
right?
Absolutely, yep.
So computers are really good at big data problems, and we've just said we don't have big data. Humans are very good at interpolating in poor data areas, right?
Yep.
And so this is, we're trying to militarize each other and get the best out of both of us.
You brought up, this was very interesting for me because I talked to a lot of different groups. The mining companies are under the impression that we are deluged with data. And how do we sort through it to prioritize? And from your perspective, more data, the better. Bring it on. We will interpret it. And we've just begun to touch the surface. No pun intended. I said I wasn't going to do that.
And there are a lot of mining companies who are going through, how do you digitize handwritten notes? You need to scan it. You need to get it into some sort of search tool. So companies like Tech have their own version essentially of ChatGPT just for their geoscience data, and they ask it questions, and it gives them back answers, but with references from where that came from. I mean, that's a wonderful idea, but you now need to take those ideas and get them into sort of geoscience models, and that's very difficult. So we're building a new facility in Adelaide that's gonna have a large compute center. But sometimes these are big investments that you have to make in the architecture and infrastructure. And we've got lots of software engineers that are working on the software that's going to use, but we're also investing in people to kind of complete that triangle.
So I want to touch on something we didn't talk about before, but I've seen in our industry, if I'm with a mining company, I'm experienced in that mining company, I'm looking at this deposit. You guys have looked at numerous deposits all over the world. That kind of expertise often the mining company doesn't have, right? So now you can look at it and say, well, this deposit here, we looked at something similar in Adelaide, or we looked at something similar in Kazakhstan or wherever, I don't know. But the experience you bring from seeing a whole range of different deposits is something that is hard for mining companies to come by.
I expect so. Yeah, I mean, I guess a lot of companies have very well experienced geologists and geoscientists, so it depends on the scale of the company as well.
Yeah.
But yeah, you certainly get exposed to a lot of different deposits, but it's not only the deposit; it's the actual environment of the deposit as well. Often the geophysics is not characterizing just that small space; it's characterizing something larger. So, one of those really interesting surveys has been when we did something very large, 180 kilometers by 40 kilometers down to 5 kilometers. So we're then thinking about what is the whole architecture, what is the big sort of structural zones that are important. And then we go in and then you're looking at a smaller scale features, which packages of rocks can we see and what is their three-dimensional architecture. And then we go even to the smaller scale and then we're starting to see not only the rock type, but processes which overprint that rock type, we call alteration, which can be important for mineralization. So you kind of have this sort of scalar, different scales of observations telling you something different at each time.
I'm picturing Google Maps.
Well, it is like that.
Look at the countries, province, city, then I can see the street names.
Yeah,
And then if you go the next one, you can see a picture of a house.
absolutely. Yeah,
You're
could-
just
yeah.
each stage.
That's the idea. In
Yeah.
fact,
That's the dream.
Yeah, to be able
it's
to.
difficult to build, but that's the dream.
Mind maps.
Yep.
Instead of Google Maps.
So I've been very fortunate to work for contractors all over the world. Little tiny stints in mining companies, and you're right. You get to see a whole lot of different deposits, and it's very exciting.
And you can bring that to your
And you
your
can,
customers. Yeah.
But I think you need that. You also need that very detailed understanding of certain deposits. I mean, you're getting to fine scale mineralogy, and
Yeah.
you'll have someone who's worked on that deposit their entire life. If you can marry those two things together, I think that's powerful.
Definitely.
That partnering, that working with the client and
Absolutely.
sharing your experience with their local experience is a winning
That's
combination.
it. I mean, I like to say to clients that we're not just one of these data slingers. We don't just, here's your data, buy.
Yeah.
That's not at all what we do.
Yeah.
We really, like having long-term relationships with clients. We give you a geological consultant whenever we're working with you that gets sort of embedded and tries to understand what you're trying to achieve, but then brings some of this wider experience with our data and our processes to kind of act as a conduit between us. But that's it. We like longer-term partnerships.
That's that triangle you just talked about, right?
That's it.
With the technology. Anyway, yeah, I think there's a parallel there.
For sure.
This has been very, very illuminating, and thanks. I enjoyed our discussion before the session, and I enjoyed talking with you on camera, and there's nothing we're going to edit. It's all great.
Perfect.
Just put it all in.
So I shouldn't say that because we aren't done yet, are we?
What's the next
no.
question? Here we go.
The next question is the final question. What thoughts would you like to leave with our audience?
I think one of the key things about deciding which geophysical methods you're going to use, that's where I'll take it, is you've got to remember that each individual method is measuring one or maybe two properties in the subsurface. So no single method is going to give you the answer. It's always a multiple method, multiple
Because of the
methods are required.
complexity of what you're dealing
Yeah,
with.
because you need to understand different types of minerals. They have different properties, and not every method you use is giving you, the answer. It's telling you about one aspect of it. So data integration and thinking about it holistically that's the way to solve problems.
I'll sort of into a bit of a bigger picture on the exploration industry. And as an industry, every year we only have so much money to spend, right? Money doesn't just come from nowhere, and we get to put that money into the ground. But let's do it in a data-driven way. Let's make our decisions based on data. There's no space in the industry, I think, anymore for pet projects.
The most bang for your buck.
Absolutely. Absolutely. So let's be smart about how we spend that money, where we're applying it. If a project's not economic, you need to walk away. And some, it's very sexy to talk about this geophysics and we drilled this deposit, etc. Really good geophysical surveys, they can show you there's nothing there.
Yeah.
That's just as valuable because it means you can focus your money. As an industry, we can focus our money on other places.
Feasibility means it's feasible or not.
Exactly.
It doesn't mean how do you get it approved.
Correct.
Right?
Correct.
Yeah.
Right.
Very interesting discussion. And I've been speaking with Anthony Reid and Darren Burrows from Fleet Space Technologies, a very interesting company. Gentlemen, thank you for joining us today. And thank you to our audience for joining us for another edition of Mining Now.